All right, so I'm not sure who's familiar with this 1 billion row challenge. Anyone? This was quite a news like 2 to 3 months back, right? It was on the first page of Hacker News for quite some time, I believe, like maybe a week or more. And this originally was so the original task was to write a Java program, right? Where you read a file, you calculate the mean, median, not median, mean, minimum, the average, and the maximum value of 1 billion row file, right? So basically, it's pretty easy. On the left-hand side, you have all the, they call it the weather station name, or rather city, and then separated by a semicolon, and then you have the values of the, I believe, the temperature, right? So what you need to do, the challenge is that you need to take the file, which consists of 1 billion rows, and then produce a result, which is on the right, namely the station name, and then provide the minimum, the average, as well as the maximum temperature. So you need to first sort the station name and also do aggregation, right? So you can write a Java program for that, but at ClickHouse, we obviously, it's a database, and we want to see how far we can push this, right? Java isn't that great, by the way. So if you if you like to, you can go to the 1 billion row challenge repository. You can actually see the different implementation that people have submitted. These are on Java. But today I'm going to show you how we can improve the query's performance using some tricks and tips from ClickHouse. So the next thing here is that first, we need to generate a data set, right? So we are generating data set using the Python and as well as the Java. So the Java code, the repository actually provides a Java code, right? So basically, you read in a file, we call it a station file, and then you run the create measurement script. Basically, it's a underneath it runs a Java program, and then on my setup, which is a server running on a 32 gig of RAM, and I believe like 8 cores. As you can see, Java it's awfully slow. It's 7.2 minutes. It's way too slow. Python was 13 minutes, right? So of course, ClickHouse can beat that. Anyone want to guess how long ClickHouse took to generate 1 billion rows of data with the mean and variance of 10? Any guess? So this is in minutes. No one? Come on. No? Okay, that's fine. I'll show you the result. So in ClickHouse, we can actually generate this in 1 minute. And anyone want to see the demo? Maybe I'll just show you, right? Since I already have it. Okay, so we prepare this function. This is a query, uses a function that writes into the measurement.csv file. I have another slide that I'll go through each of the component of this query. So before that, let me just run it. Can you see? Good. All right. Before that, let me just remove my existing. Okay, it's going to take some time, but I promise you it's not 7 minutes or 13 minutes. I'm going to switch out and I'm going to show you what the query is talking about. So essentially, this is a query. Any SQL user would be familiar with insert select, right? So on the overall, like we are using insert select, we are inserting into a file measurements.csv. We are selecting from some very strange looking functions over there. But what are we doing, right? So let's drill down. So this is the file table function. It basically writes data into the local file system, right? So essentially, we will be receiving a measurements.csv at the end. This is the insert select here, and then you can see that this is a CTE, right? So why are we using a CTE? Now, the reason is because we have a station.csv that is pre-generated. There are 413 distinct stations that we are retrieving from. So basically, these stations are the seed data, right? So with that 413 station, we are generating 1 billion rows from that. So we are getting the averages, and then we are using group array. So what does group array give us? So group array, you can see from here, this is the example. We will end up having an array of a tuple, right? So the tuple has like 2 elements. One would be the station name. The other one would be the average. And from there, we are doing some magic over here. So you see the select statement here. We are selecting the first item as city, and the second item here as the temperature. Now, of course, we are not going to select whatever that's present in the CSV because we are generating data. So you see this second part of the function here, and this is us using the random canonical function, and we are using this to generate using a Muller transform, whatever that is. Anyway, this block is not written by me, but I basically just execute it and reproduce this. So what this means is that you're just adding variance, right, to a reference station average, which is coming from station.csv. And because we want 1 billion rows, we are using a numbers table function that generates 1 billion rows. So, which is why you will have city, you will have temperature, and then 1 billion rows from there. Now, the last thing which might be interesting is the settings that we are using here. We are using a special delimiter, which is a semicolon here. And that's to help us generate that CSV. So now, before I switch back to the terminal, anyone want to guess? This is my second calling. Come on, Johnny, what do you think? 1 minute? Really? 90 seconds? Okay, quite close, but let's see, right? So yeah, 70 seconds. So still pretty good, right? So we have Python taking, I don't know, how much? 13 minutes, Java 7 minutes, and then ClickHouse 1 minute. I think if I use a faster disk, I might even go below 1 minute, right? So I explained this, how we generate the data set. Now using this measurement.csv, we can then generate some baseline. So again, we have to go back to Java because that's the challenge. So the repository actually provided a baseline. So using Java, it's actually 4 minutes and 41 seconds. And then using ClickHouse local, so this is me running the measurements.csv and then formatting it accordingly because they want us to format the results like this. So I'm just going to show you actually, I'm just going to run it, and then I'm just going to describe what's going to come out. So this is how ClickHouse is running. You see the number of millions of rows being processed per second, including the megabytes per second, and also the resources that is being used while it's running. So you can see that this should complete really fast, but it's not that fast actually. Why? Because we are reading off the CSV linearly. We are basically scanning through the entire CSV. So this is never good, right? You're doing a full table scan. Now the results come in this shape, which is required by the challenge. You see each of the, first of all, you notice that the station name is sorted, right? It's sorted by alphabetical. It's pretty good, as well as the value. So this is the minimum, the average, and then the maximum. And how long did we take? Okay, 22 seconds, pretty good. So this is rather, so you see 412 rows. So meaning to say like there are 412 distinct stations. So elapsed time 22 seconds, pretty good. But can we do better? You think we can do better? 22 seconds? Yes? Okay, how much better? Make a guess. How many seconds? Half it? Half? Okay, let's see. I think we can do more than half. So let's see. So this is us reading from a file. Like I said, it's doing a full table scan is inefficient. I mean, linear scan of the file, right? So in ClickHouse, there are many ways to optimize the query. So one popular way is to make use of a materialized view. So materialized view, it's Johnny has mentioned before, it's a insert trigger. So what happens is that it will watch over a base table. So when you insert data into the base table, the computation is done on insert time. So let's take a look, right? So on the left, which is the first step, we are creating two tables. One is the weather table, the other one is the weather results. Now you can see that the weather results is using a special engine. It's called the aggregating merge tree. So what is an aggregating merge tree? So this is something for us. This is something for the materialized view to insert into when we insert data into the base table, which is the weather table, right? And then in the second step, you create a materialized view. This is the view name. it really doesn't matter what you name it as. More importantly is that you want to store the results of this select statement, okay, into the weather underscore results. Now, what this means is that when you have data coming in and writing into the weather, like from weather, you see here, select all these from weather, this query will run. Basically, this query will run, and then you get the results being pre-computed in during the insert time. So essentially, what this means is that we are shifting the computation from the select time to the insert time, right? Now, should I just run it and show you the magic? So I'm using ClickHouse Local. So ClickHouse Local is actually a just a binary, right? So you can, so first of all, ClickHouse is a single binary. Anyone can download. When you download ClickHouse binary, you just call ClickHouse-local. It will activate the local within that binary, and then that's what I'm doing. So you don't need to start a server. You can run it on a Raspberry Pi. You can run it on your Mac. It's all well and good with one binary. So what I'm going to do is to create the two tables over here. Okay. And then creating the materialized view. Okay, so nothing actually happens right now. So so what this means is that weather has like no data, weather underscore results has no data as well. So the magic happens during the insert time, right? So see, when I'm so what am I inserting? So I'm reading off the file, which is measurement.csv. This has 1 billion rows. And after that, inserting into the weather table. See, when I do this, I have no mention of weather underscore results. Neither do I have any mention of weather underscore MV, which is materialized view. Now, but when this is happening, at the background, ClickHouse is already pre-computing the minimum, the maximum, as well as the average state, the results for each of the city. So it's going to get done pretty soon in terms of the insert. So once the insert is done, selecting or rather querying from the results of the materialized view is going to be super fast. And this is the, I would say, the hidden trick or optimization trick that ClickHouse has. So what I'm going to do next is I'm going to write the same query. In fact, you can see here it's very similar to using the file table engine, but this time I am querying from weather underscore results. So how fast would it be? Do we have any guess? Why are there 2 billion rows? Because there's insert and there's select, right? So you are selecting 1 billion row and then you're inserting 1 billion. Yeah, any guess? So I'll give some hints. It's going to be seconds, maybe milliseconds, 0 seconds. Nah, how is it possible to be close to 0 seconds? Yeah, but give me some numbers. Maybe we can give up some swag if we get some close numbers. Let me give some hint. It's going to be milliseconds. It's going to be 600 milliseconds, 300 milliseconds, 10 milliseconds. Okay, who's the one with 10 milliseconds? Nice, very hopeful. We will live up to your expectation. Let's see. Anyone else? No? Okay, let's run it and we will find out. Boom, 26 milliseconds. You see that? So, I mean, I can run it a few times. You're going to get the results. It's the same thing. Now, same thing. The reason is because we are reading off a table that already has the results being pre-computed. And this is already done during insert time. So 17 seconds. And then if I were to run it multiple times, it's going to vary, right? Because we have the file system cache that is being enabled. And with that, we managed to lower the query duration from 20-ish seconds to 14, 20 milliseconds, and that's roughly like more than 1,000 times speed up if you were to run and use materialized view correctly with ClickHouse. And that's all I have. Any questions? You get a swag from me, I promise. Thanks for that. Yeah. How would the insert time be affected? Yeah, right. Actually, as you can see, like, I put the results here, and I think the insert was pretty fast. How much was it? 20 something seconds, yeah, 23 seconds, 24 seconds. It's pretty okay. So, this is actually faster than reading it off the file, right? I mean, when I read it off the file, how long was it? 23 seconds, right? So this is essentially nothing. It's the same as like us reading from the file, as you can see here, reading from the file, it takes like 20 seconds. When I insert, it's also taking like roughly 20 something seconds, right? So it's not going to affect insert by a lot. But obviously when you do an insert, something is running, right? That select statement is running. So in fact, what's cooler is that ClickHouse support a concept called a cascading materialized view, meaning to say like you can chain, you can do roll up, basically a materialized view that watches for another materialized view that watches for another materialized view that watches for finally a base table. So anytime you insert into a base table, all these will run, and then you get results pre-computed and stored in storage, waiting for you to do your queries. Yep, sure. Mhm. Insert. In insert. So the slowness doesn't happen. So let me quantify like the slowness, right? Would there be any slowness? I would say yes, it's going to affect slightly, but why, right? So where is the bottleneck? So typically the bottleneck is on CPU, right? Because every time you insert, it needs to process the block of data that is being inserted. So but if you provide it with a ton of CPU, you basically don't see any slowdown because the CPU is sufficient, and it will just run as fast as the I/O of the disk allows. Do we have any questions? No? All right.
All right. Just want to say thank you, everyone. Thank you to the speakers. Thank you for attending today. We're going to hang around a little bit, but please join some of the community Slack, some of the community pages. I just had a quick look. There's almost 7,000 community members on the Slack channel, which is great. We're constantly answering questions as well. So please jump on and feel free to reach out to us. If anyone wants to speak at a meetup in the future as well, please let us know. We're definitely going to come back and have more sessions for ClickHouse users in Singapore. And yeah, so we're going to hang around a little bit more. So thank you very much for your time, and Shopee for hosting as well. So thank you, everyone.